So we're going to look at MRI in a little bit more detail here. So MRI scanners, so patient's positioned in the centre of the bore, they're immobilised or the limb is immobilised and need to stay as still as possible for around about 30 to 90 minutes depending on what area of the body is being imaged. So there's different sequences, the high signal, hyper-intense or bright white, low signal, hypo-intense or dark or black, and intermediate is iso-intense and iso-intense, and is shown as grey. So there's different sequences that go along with that. So start off with T1. So T1 weighted sequence is the fluid is shown as dark, fat is bright, and muscle intermediate. So this is your basic anatomical sequencing. And it shows here, so what shows as dark all the way up to what shows as white on a T1 weighted sequence. So here shows some examples here of the imaging using a T1 sequence or T1 stir sequence. As you can see on these images here, you can see that there is this disruption of the scaphoid here, and because it's shown dark, you're looking at there being an issue or a fracture on the scaphoid, which previously wouldn't have been seen on this X-ray here. Then you've got your T2 stir sequences or T2 weighted sequences, whereby fluid is bright, fat is bright, muscles intermediate. This is your physiological sequence. So looking at the images here, you can see that the fluid here is white. Looking here, fluid white again, and you can see that there's an issue here, some form of tumour sitting within there. Okay. So PD sequence is based on the number of protons and literally means proton density weighted MRI scan. So fat is shown as high density, fluid is a high density of protons, muscle intermediate. Normally used in MSK because it differentiates really nicely between those structures and shows a distinction between fluid, hyaline and fibrocartilage. In here we've got a proton density sequence, but with fat saturation. So the fat saturation reduces the fat signal so that the fluid stands out more. So you can see in relation to this one here, you've got an issue with the ACL attachment. So looking here, you've got a fracture of the tibial spine, but you can see the ACL as it sweeps back through here, and actually the ACL looks normal, but you've just got this almost avulsion fracture of the tib spine. So as I've said previously, the fat saturation signal reduces the fat signal so the fluid stands out more. It's a differentiator between tumours and bone marrow edema. So you've got T1, T2, and then proton density scans. So it might be worth here just making a list of the uses for T1, the uses for T2, and the uses for PD, and also when you might refer for each or when you might need each type of sequence done for MRI. Looking at the spine, it's normally a 4-minute sequence, normally within a 30-minute slot. And it's the same for all examinations of the spine. So you're looking at the different sequences as you go through. So you can see here you've got a T1, then you've got a T2, then you've got a PD. Looking at the MRI scan shown here, you can differentiate between L3 nerve root, you can see the neuroforamen, and again here, looking at the neuroforamen just here, these little sections that you can see. So depending on your sequencing, you can see aspects of the spinal detail in really quite nice specific detail when you're looking. So if we go forwards onto looking at alignment when you're looking at an MRI scan, you're looking here at both a retrolisthesis and a spondylolisthesis. So looking at that anterior and that posterior slip of the L5 vertebra, either posteriorly or anteriorly. So first thing you're looking at when you're looking at an MRI scan is you're looking at that alignment. Similarly, when you're looking at alignment, you may notice things like a scoliosis, so an S shape within the spine, or looking at reduced lumbar lordosis. So you're not getting those natural curves of the spine itself. So as you can see here, it's really flat into the lumbar aspect of the spine. You can also see the discs. So as is demonstrated here, you can see the end plate of the vertebra. So if we just look straight across, and then you've got the disc itself, nucleus within the middle, and then you're looking at the annulus fibrosus rings that sit around the outside of that. So looking here, looking at the nucleus within each disc, then you've got the annulus fibrosus that sits around the outside of each, and then looking at the quality of the bones themselves. So this shows how dehydrated the bones get, because we're actually looking at a 3-year-old here, we're looking at an 18-year-old here, and then we're looking at a 57-year-old. So you can see the quality of the discs, so how bright white they are in the middle, and as it reduces, obviously the disc is dehydrating because you've not got that fluid sitting in the middle. You're looking at the height of the vertebrae themselves, so nice square building blocks in the 3-year-old and the 18-year-old. You can see that there's some degeneration and some lipping onto the vertebra into the 57-year-old. And again, you're looking at these bulges here, so bulges of the discs posteriorly into the spinal cord, spinal canal, sorry. And again here, this looks nice and flat. There's no disc bulging here. Looking at this one, so this looks like a pretty rubbish MRI scan. So you're looking at wedging of T12 there. So again, it's not sitting nice and square. You've got some wedge fracture there. But it's not compromising the neurological aspect. There's no issues with it protruding onto the spinal cord. You've got some signs of degeneration. You've got some hypertrophy of the facet joints here. But again, there's nothing there that you wouldn't expect within a normal degenerative spine. Looking at discs, so you're looking at disc protrusion, extrusion, looking at sequestration here. And this is just your disc classification. So you're looking to see whether or not there is any evidence of protrusion, extrusion, or sequestration of disc on the MRI scans themselves. So as you can see here, you've got a disc bulge here, and then looking at the images that you can see here. So this section here, you're looking at the cerebrospinal fluid, and then sitting underneath that, just here, you're looking at the exiting nerve root just underneath here. When you're looking to either side, you're looking at the facet joints that sit either side of here, and then looking up into these aspects are just changing sequence just slightly further up into here. These are your exiting nerve roots here. So you've got your exiting nerve root, you've got your cerebrospinal fluid just sat within here. Then you've got your nerve root itself, which is this section here. This line here is your spinous process. And then looking over to these sides and aspects here and here, you're looking at your lamina. So again, it's just orientating yourself with the images that you're actually looking at. So here you can see you've got loss of disc height here, and then stenosis because it's impinging onto the spinal canal itself. So you've got potential retrolysis here, and you've also got disc protrusion here. And again, here it's just looking at the quality of the discs, and also the exit foramina that you can see opened up quite nicely on this image. So annulus tears are not as easily seen on T1 weighted sequences, but it's shown here on this T2 sequence. You can see you've got this area of higher intensity just here, which would indicate an annular tear of the disc. So this is white section here. Images show different aspects of inflammation, whether that's caused by use of steroids or sclerotic changes within the vertebra themselves. Okay, and then looking forward, you can see even just by a rudimentary look over some of the MRI scans, you can see that there's areas that potentially you would want to look at in more detail. So it's being able to look down that MRI scan and perhaps scroll through when you're circling on something that doesn't seem quite right, and you might want to investigate that in a little bit further detail. So whether that be on a T1 sequence or a T2 sequence, or you see something really quite bright white that doesn't seem to fit with anything else, you want to be investigating that. Is that a tumour? Is that a cyst? Again, you don't need to make that diagnosis, but it's being able to notice that there's something that's not quite right. Looking at these ones just here, you can see you've got crush fracture of the vertebra here. Looking at this here, so this doesn't look right. So you know, based on looking at disc pathologies and looking at discs in general, that this expansion of the disc and destruction of the vertebra itself would indicate that there is something going on here, whether that not be bony mets that's causing destruction. Looking over here, you can see there's some extrusion of the disc itself. Is that a fracture of the vertebra? Is it that there's some degree of tumour that's sat within the spine itself? So again, you don't need to make that decision. This one here doesn't look quite normal either. You don't need to make that decision or that call. It's just being able to recognise it. Looking here, you can see there's some inflammation of the costovertebral junction. So where the ribs insert onto the vertebra themselves, there's some inflammation sitting around there. You can see it looks different to the ones below and above. Looking at the shiny corners. So shiny corners are an indication of ankylosing spondylitis, representing the reactive sclerosis secondary to that inflammatory erosion of the end plates of the vertebra themselves. And then looking at Anderson's lesions, which are shown quite nicely here, and these are an inflammatory involvement of the intervertebral discs, again an indication potentially of ankylosing spondylitis. This is an indication of epidural lipomatosis. So this is an abnormal amount of fat that is deposited on or around the lining of the spine, and it may press onto the spinal cord. So you can see this here, this is an abnormal amount of fat here, and then this little dot here is the cyst that is associated with that condition. Looking here at spondylolysis, which is a defect or stress fracture in the pars interarticularis of the vertebral arch itself. So you can see here that potentially you've got that spondylolysis here, and then that can lead to your spondylolisthesis later on. So going on from here, I'm going to put up another screencast where we'll look at some case studies. So feel free to go get yourselves a drink, and we'll move on to the next screencast in just a second.